So let's go ahead and have a look at the ratios for these rectangles. We are going to make a ratio between the height and the width. So let's go ahead and put the height on the numerator and the width on the denominator. So for the first rectangle A, we're going to have a ratio of 12, 20. Now, for rectangle B, we will have a ratio of 10, 6. For rectangle C, we will have a ratio of 15 to 9. And we will also have a ratio for rectangle D for 6 to 20. So what's really important is to reduce these ratios. So let's first talk about rectangle A. You can reduce 12 over 20 and reduce it to 6 over 10. But I can still reduce it a little bit more. I can reduce that to 3 over 5. Let's look at rectangle B. I can reduce 10 over 6 to 5 over 3. I can't reduce that anymore, but that is what I can reduce that to. Rectangle C can be reduced even further. Notice you can divide the top, the numerator, by 3 and the denominator by 3. You can reduce this and this will become 5 over 3. And I can reduce rectangle D and I can reduce it to 3 over 10. So one thing I want you to notice is that rectangle B and C have the same ratio at the end. Because they have the same ratio at the end, these two here are similar. Now, let's go ahead and have a look at their rectangles. If they are similar, then that means I can multiply 6 by a number to get 9, and I can multiply that same number by 10 to get 15. Well, what is that number? Well, we can go ahead and try to fit 6 into 9. You can either divide 9 by 6 to figure out what the scale factor is or stack it. Well, I'm going to stack it. This to this is 6 inches. Well, let's stack it into the other rectangle. If I go from here to here, let's pretend that is 6 inches. Well, 6 inches is not enough to cover that 9. I'll need another 3 more. Notice that that's 1.5 of those 6 inches. So basically, I'm multiplying 6 by 1.5 or 1.5. I can do the same thing lengthwise with the 10. This side here, and I'm going to go ahead and erase this so that you can see it a little better. This side right here, this 10 does not go into 15 easily at all. But I can try to fit it into that 15 by stacking it. From here to here, let's pretend that that's 10. Well, I'm going to need a little bit more to stack that. If I stack a little bit more, it would be 5. Notice that's 1.5 of that 10. So I'm multiplying that by 1.5. Or you can say 1.5 again. These two are similar figures, with the scale factor of 1.5. And we know that they're similar because their ratios right here and here reduce to the same fraction. These are what we call equivalent fractions.